everybody. Today is another class of physics. This class is for grade 10 and this will cover our classes on week 6. We still at the same block number 4, and this presentation or those slides are delivered by me, Mr. Khalid. Today we are going to discuss another new topic, which is on page 272. 272 and 3. Start from page 272. Electric circuits. So electric circuits here. We will start with the circuit diagrams, as we can see here in this figure. So the circuit diagram here, or this figure is figure 42, is a simple circuit diagram that shows how a torch is powered by a battery consisting of three 1.5 cell. This is one, this is the second one, this is the third one. Three batteries connected in serial. Which they have the same value, 1.5 volt. So giving the total is 4.5 volt. So 1.5 plus 1.5 plus 1.5 is equal to 4.5 voltage. So the circuit here is what we have: a normal switch. This is a switch on off. This is a lamp, and this is the power supply or cell or battery or anything here. This is the source of source of voltage. This source going to is used to going to push the current to go through this circuit. So current start from where? From this part or this point, the positive one, and moving through the circuit like this until comes back to the minus part, and then again this way. This is the direction of of current I. This is the direction of I. So when the circuit is open like this, so there is no current going to move through the circuit until when? Until we close this switch. So switch off, current is passed. Switch on or open. If the switch is open, there is no current. Okay, now so in the case of this example here in the previous circuit, the previous one here, a circuit diagram of torch. So in this case of the torch, the cells are put in in separately. But in the case of 9-volt battery, for example, if we have 9-volt battery, for example, so the 6 cells are pre-assembled by where? By the manufacturer itself. So the word battery means an assembly of several cells to get the value of 9, 10, 12, 20 volt, whatever. But people often use the word refer to a single cell. So they usually use this one or this word refer to single cell. So you can say cell, you can say battery, you can say power supply. It's the all gives the source of fault. The source of fault goes to push the current to move through the circuit. So to calculate the combined EMF or voltage of several sources in series, you add individual. So this is the summation of them. If we have several sources like this is 1, 2, for example 3, we need to put them together, or the summation of individual V1 plus V2 plus V3, or EMF1 plus EMF2 or plus EMF3. So just you add them together. Also, we have another important thing here. The positive terminal of the cell is indicated by what? Long thin line. The positive is always, the power supply is like this. We mention it, the symbol of it is like this in the circuit. One of them is short and the other one is long, like this. This is the -1 and this is the positive 1. Current start move from where? From positive to minus. From positive to minus. So positive terminal of the cell is indicated by what? Long thin line, and the minus terminal by short thick line. To help you remember, imagine yourself cutting what? The long thin line into two shorter pieces and turning them into plus. So just remember that if you cut this line in two parts and then add them together, so you will get what? The positive terminal. Just remember that the long one is the positive part, the short one is the minus part, and current is the important thing. The current start moving from positive to minus. The other symbol in the circuit, previous circuit, was the open switch. Is the what? Switch and the lamp. Switch and the lamp. As we describe it where? In this circuit here. This is the source of battery or the cells. This is the first one, positive minus, sorry. This is the first one and this is the second one. They are connected in series, and this is the third one. So the total value is Phi1 plus Phi2 plus Phi3, or EMF1 plus EMF2 plus EMF3. Okay. Now turn on page 274, please. In this circuit, figure 43, in this circuit here, the calculator is presented by what? Calculator is presented as a register. So what we have here in this circuit, a calculator is far more complicated than that, but it does behave to the battery as if it were a register, drawing a small current I out of the battery. We have what here? We have a source of battery, 9 voltage here. This is the first one and this is the second one. Both of them together, they giving 9 volt. So we have what here? This is a current moving through this one, what they call resistor, and then this is what? The calculator. This is the positive part because it's connected to the positive part here, and this is the second point here is connected to the minus part here. This is the first point and this is the second point. If we change them here, as you can see, the row on the diode, this is a diode, we will discuss it later. This is a diode. A current move through this diode and through this way until get back to the source of voltage. So the diode shows the direction for conventional current. When the battery is inserted the wrong way round, there is no current. If the battery is connected like this, if we swap this source of batteries, change positive with minus, so this is the -1 connected with the +1, and the minus point here is connected with the positive, so there is no current moving through the circuit. This source of power or power supply is not able to push current to go through the circuit because the connection is not correct. It's wrong. This one is wrong connection. This one is the correct one. In figure 4.4, there is circuit symbols that you need to know. This is the famous one, the most general one you need to keep in mind, because we are going to use them later from now and so on. This is an switch. This is a switch, a symbol of switch. It's open. This one is open switch. This one is closed. This is a lamp. This is a voltmeter. This is a meter. This is a battery. This is a cell. Different kind of things here. This is a register R. This is a constant one, have one value. This is what variable resistor. This is what adjustable resistor. It can gives different value of R. Resistor, this one, it gives what? Only one value. And different kind, this one a transistor, this one a relay, this one a code, this one a bill, different symbols here. You need to keep those in mind, especially source of voltage, battery, cell, resistor, variable resistor, ammeter, voltmeter. They are very important. Open switch, close switch, and the lamp. Okay, now turning on page 275, we will say how can we connect circuits in parallel and series and parallel circuits. There are two different ways of connecting what all those components or some of them or other component to the same battery. So there are two different ways of connecting two lamps. If we have two lamps here, this is one, this is another one, two lamps. There are two ways to connecting them to the same battery. The two-way different kind of circuit can be made. These circuits are called what? Series and parallel circuit. Series and parallel circuit. So this is the first one, which is a series one. In series one, there is exactly the same what value of what electric current. So the current start moving from where? From this part, positive to the minus. So we have what? The same always in series connection. Current is what? Constant. I is, we have the same I here. On the lamp one, the same current. We get the same current here or any point here. But what's different? The different is what the voltage is shared between what two units. The voltage here, the value of total one is divided between the two sources here. Whatever the source is, sometimes is a lamp, sometimes is a resistor, sometimes is a diode, sometimes any component. So the voltage here is divided between two components here. If we have a resistor here, so the value of V is depend on what? Depend on the value of R. Sometimes we can get 6 here, 6 here. For example, 2 here, 10 here. It depends on what this component. So the conclusion of this, when you have a series connection, so current what is constant, and we have what? Different value of V. V is divided between components. The opposite exactly with what? In parallel circuits. In parallel circuits, in circuit like this here, we have what? The current what will be divided. The current will be divided with part of it going through each component. So if we have a switch here or a power supply here, if the current comes from this way here up to here, so current here will divide it between this and this way. We have I, for example, 1 and I 2, and this is what the total I is what? Divided. When I is reached to this point here, will divide it between the two parties, I1, I2. I1 plus I2 will give what? The total I. Again, I2, when it reach here, when I2 is reached up to this point, will again divide it to what? For example, I3 and I4. So I4 plus I3, it will give what? I2. I2 plus I1 will give I. And then this I will continue move through this part. Here, this is I4, and we have, when we turn the switch off here, we have what? I3. So I4 plus I3 will comes again from this part, which is what? I2. I2 is added with what? I1. I2 comes from this point and I1 comes from this point. We will get what? The same original value I. So in parallel, current is divided between components, whatever the component here, and the voltage what is constant. The voltage is constant. So the current is divided with part of it going through each component. All of components or appliances in-house are connected what? In parallel, where to the power supply or to the source of supply, and each one receives what? The full 110 volt or 230 volt, depends when you are leave. So the two great advantages of parallel arrangement are what? That each appliance can be designed to work with the mains voltage supply, and that the appliances or the sources can be switched on and off individually. We can say one example here. Say here, this is a city, a big city here. Say the lights here, all of these lights here in those buildings are connected in what? In parallel. It's possible to connect them in series. If you are going to connect them to the series, for example, if the current come from this side, so if something wrong happen here, so the light will be destroyed or disconnected to all those buildings. But when you connect them in parallel, if there were in here, if something happen here, no, it gonna switch off the current on this part, but all the other parts is still working. So it's what? This is the big benefit or the most advantages of connecting in parallel. Okay. Here in this table, there is a comparison between what? Series and parallel connection. Circuit diagram, as we discussed it before, is like this. All components are in serial. Those ones are connected in parallel. So current here, the current in series is same. Current here is different. Voltage are different. Voltage are same. So the lamp here, both lamps have what? The same what here? Brightness. But lamps are what? Dim. So the current same, voltage are not. Here, both lamps have the same what? Brightness, but both of them what? Bright. So current is different, voltage is same. Battery, the source of power or power supply here, the battery is having what? A hard time pushing the same charge first through one bulb, then another. This means what? Less charge flow each second. So there is a low current and energy is transferred slowly from the battery. Here is no, it's different. The battery pushes the charges along two alternative paths. This means more charges can flow around the circuits each second. So energy is transferred quickly from the battery. Switches, if we say the switch in first one here and here, the lamp cannot be switched on and off independently. No, here cannot switch. We can switch this one on and this one off, or this one on and this one off. No, it's not possible. In the second circuit, the lamp can be switched on and off what? Independently. by putting switches in parallel branches. Advantage and disadvantage in serial connection or series connection. A very simple circuit to make. It's very simple circuit to make. It's not complicated. The battery will last what longer? Will last longer. If one lamp blows, then the circuit is broken, so that other one goes out too. Here is different. One lamp blows, the other one will what will happen to the other one? Will keep working. They are is not affected by the first one, so the battery will not last as long. Examples for series: 3 lights are often connected in series. In parallel, electric lights in the home are connected in parallel. So this is one example of series connection, and this is another example for parallel connection. Okay, this is all for today. We have covered how circuits are connected. We have 2 very important connection, series and parallel. We say what happened to the current in series, what happened to the voltage, and what happened in current and the voltage in parallel. We say different things here. What's the advantage of this? And one example of series, and one example of parallel, and what's the advantage of parallel connection. This is all for today. Thanks for listening, and we will see you next week, inshallah.